Alright, in this video we're going to look at some problems where we factor trinomials that have a greatest common factor. In these trinomials, once we factor out the greatest common factor, they're going to be of the form x squared plus bx plus c, meaning the value that's in front of the x squared is a 1. So the general format for trinomials is ax squared plus bx plus c. In this case, they're going to have an a of 1, so they'll look like x squared plus bx plus c. That is nice because when that happens, I do not need that AC grouping method that we were working on yesterday. I can go straight to my two binomials. They will both have in this case, x in the front, and then I'm looking for the two numbers to put in that have a product equal to c, and they have a sum equal to b, which is the coefficient of the x term here. So let's see how some of these go. So first I'm going to factor out a greatest common factor. And then I'm going to identify the c in my problem. Look for the factor pairs of c, and I'm searching for one that has a sum of 11, because b is 11. As soon as I find that, I'm ready to factor. I know my first terms are both x, because x times x gives me the x squared, and my second terms are plus 3 and plus 8. Alright, we'll do the same with the second problem. First factor out a greatest common factor. Identify c, in this case it's negative 20. When I have a negative number, that means that the two numbers that multiply to make it, one has to be positive and one has to be negative. I notice here b is negative 1, so when I add the two numbers, they add to negative 1. So when I'm looking at the pair of numbers, I know that the larger of the two has to be negative, so they add to a negative sum. So when I do like 1 and 20, if I put a negative in front of the 20, that adds to negative 19. And I'll keep going until I get the one that adds to negative 1. So then the 4, positive 4 becomes the y plus 4, and the negative 5 becomes the y minus 5. In this case, my two numbers multiply to make a negative 6, and they add to make a positive 1, because b was a positive 1 here. So I know that one's negative and one's positive, and the larger of the two has to be the positive, so they can add to a positive number. I find my pair. So the negative 2 gives me an x minus 2, and the positive 3 gives me an x plus 3. Remember again, the order doesn't matter. I could have put the x plus 3 in front and the x minus 2 behind. It would not matter because it's all multiplication. In this case, I have c equals positive 80. And when c equals a positive number, that means the two numbers that multiply together have to be the same sign. I notice here b is negative 18, so if the two numbers are the same sign and they add to a negative, they must both be negative. So I'm looking at negatives as my factor pairs. Now on this particular one, it could be that you had thought of 8 and 10 adding to 18 and multiplying to make 80 right away, in which case you wouldn't necessarily have to write all of the factor pairs to get there. this one is the first one we have that not only does it have a 2 as the greatest common factor, but all the terms have the same variable. So I look m to the 5th, m to the 4th, m cubed. So m cubed is the limiting power. So I know all of them I can factor an m cubed out of. So I'll end up with m squared plus 8m plus 12. And I can always double check that if I distributed back, I would get back to my original trinomial. Alright, one final problem. Again, this one has a 3 as part of the greatest common factor. I notice each term has an x in it, and the limiting exponent is x to the 1st. And I see some y's, but I notice there's no y's in the first term, so y's can't factor out. So just the 3x. Alright, so we have c equals negative 30 and b equals 13. They have to be different signs and add to a positive 13. So I found my match. And the only difference in this problem is it has two variables. So at the front, I know I have the x and the x, and at the back I'm actually going to have a y and a y to get the y squared, and then I just put in the two numbers for my factor pair, so minus 2y and plus 15y to finish it off. Alright, I hope that was some good practice of factoring out a greatest common factor and then factoring trinomials where a equals 1.